Hello everyone, welcome to my channel Ankura Education. Our today's topic is basics of electronic devices and circuits. First of all, let us discuss about what is meant by electronics. Electronics is that field of science and engineering that deals with the electronic devices and their uses. An electronic device is a device in which the conduction takes place due to the movement of electrons. Then, electronic devices find applications like amplification, rectification, control, and generation. In electronics terminology, anything that occupies some space and has certain weight is called as a matter. This matter can be divided into molecules without changing its identity. These molecules are further subdivided into atoms. Now, let us go to Rutherford atomic model. This was proposed by Rutherford in 1911. According to him, an atom has a nucleus at the center with electrons revolve around it. So, this as nucleus, and this nucleus contains protons which are positively charged. The mass of the atom is concentrated at the center, that is at the nucleus. The proton in the nucleus carries the charge of the atom, so it is immobile. The electron will be moving around it in a closed orbit manner. Then there exists a force of attraction between the positive and negative charges. This force of attraction follows the Coulomb's law. According to Coulomb's law, the force of attraction is directly proportional to the product of the charges and inversely proportional to the distance square. Here, Q1 and Q2 are charges and R is the distance. So, from these two equations, we get F is equal to Q1 Q2 by R square, F proportional to Q1 Q2 by R square. This is the basic Coulomb's law. Assume that the orbit of an electron around the nucleus is a circle. If we want to calculate the radius of the circle in terms of the total energy W of the electron, the force of attraction between the proton and the nucleus is given by F proportional to E square and F proportional to 1 by R square, where R is the radius. And here we are considering Q1 equal to Q2 is equal to E. So we are getting F proportional to E square. From these two equations, we have F proportional to E square by R square. If we want to remove the proportion, we have to add a proportionality constant. So E square by 4 pi epsilon naught R square, where epsilon naught is the permittivity of the free space, that is equal to 10 to the power of minus 19 by 36 pi farad per meter. Let us consider this expression as equation number 1. As the electron is moving around the nucleus in a circular orbit with radius r and with velocity v, then the force of attraction given by the above expression should be equal to the centripetal force. According to Newton's second law of motion, F must be equal to mv square by r. Consider this equation as number 2. Since F is equal to mass into acceleration and acceleration is equal to v square by r, so we get F is equal to mv square by r. According to our assumption, 1 must be equal to 2. That implies E square by 4 pi epsilon naught r square must be equal to mv square by r. If we cancel r here, we get mv square is equal to E square by 4 pi epsilon naught r. Let us say this as equation number 3. According to law of conservation of energy, the total energy W must be is equal to kinetic energy plus potential energy, and kinetic energy is equal to half mv square. So from equation number 3, we have mv square is equal to E square by 4 pi epsilon naught r. So we get kinetic energy is equal to E square by 8 pi epsilon naught r. 8 pi epsilon naught r. So consider this as equation number Roman number 1 and this as equation number 4. Potential energy is equal to force into displacement. that is equal to E square by 4 pi epsilon naught r square into r. If we cancel r here, we get E square by 8 pi 4 pi epsilon naught r. Consider a negative sign before this expression because potential energy is by definition is the work done against the field. So potential energy is equal to minus E square by 4 pi epsilon naught r. Let us say this as equation number 5. If we substitute 4 and 5 in equation number 1, we get, if we substitute 4 and 5 in equation number 1, we have W is equal to E square by 8 pi epsilon naught r minus E square by 4 pi epsilon naught r. From this we get minus E square by 8 pi epsilon naught r. This is the expression for the energy radiated by an electron according to Rutherford model. As the radius r increases, the potential energy decreases. If r tends to infinity, then potential energy becomes 0. Therefore, the energy of the electron is more negative. The above expression is derived from the classical model of electron. According to classical laws of electromagnetism, an accelerated charge must radiate the energy. Electron is having the charge E. It is moving with velocity v or acceleration v square by r around the nucleus. Therefore, this electron should also radiate the energy. If the charge is performing oscillations with a frequency f, then the frequency of the radiated energy should also be the same. Hence, the frequency of the radiated energy from the electron should be equal to the frequency of the electron orbiting around the nucleus. But if the electron is radiating energy, then this total energy W must decrease by the amount of the radiated energy. So W should go on decreasing, so satisfy this condition. If W decreases, R also should decrease. Since if minus E square by 8 pi epsilon naught R should decrease, this quantity should become more negative. Therefore, R should decrease. So, the electron should describe smaller and smaller orbits and finally fall into nucleus. So, classical model of an atom is not fairly satisfactory. Thank you for watching my video. If you like my video, please do subscribe, share and like to my video. Thank you.